There are a lot of questions we can ask with statistics. How big is a problem? For instance, how many homeless people are there in DC? How do conditions change over time? How does the population of homeless people in DC compare to last year, 5 years ago, and 10 years ago? How do different groups or places compare? Among the homeless, how many are men, women, veterans, college graduates? And how does the population of homeless in DC compare to the population of homeless in Baltimore? How much is a lot? A 2014 count found 7,750 homeless in DC. Does that number signify a big problem? What do we compare it to? Is a program effective? Do shelters in DC provide adequate care for the homeless? Statistics. Isn't this just math? Kinda, sorta. Okay, yes, it's all about numbers, sometimes long lists of numbers, and sometimes we work with equations. You might recognize the equation for a line, where we talk about the relationship between two or sometimes more variables. And sometimes those equations have Greek letters and subscripts. Don't worry, that just means we're talking about a relationship that we can generalize beyond the data we have. But math deals with concrete measures. Think about length, width, height, area. When you were doing math, you might remember building a series of logical steps to prove something, and then it is accepted as true. Statistics looks for patterns in the data. Do taller people tend to weigh more? Do older people tend to weigh more? Statistics also deals with questions of context. Is a person's weight high, low, likely? We have to have data on other people to have a point of comparison. Is an individual typical for his or her group, or not? Is one woman's weight about what we would expect, or is it unusual? How much variation is there in how much women weigh? In the rest of the material for this week, we will talk some of the terminology of statistics. You can think of these as the building blocks, the basic ideas we need to be able to start doing analysis.